So in this video, we're going to be going over another trig topic or integration method, which is called trigonometric substitutions. And trigonometric substitutions are a little complicated, but usually they have some rules, and you can either memorize this rule or you can actually memorize using the right triangle. So you're gonna have to understand how to use that right triangle for trig, and but sometimes you can just memorize the rules, because I'm just gonna list the rules right now. So trig substitutions usually work for the integrals of the form so they usually work for, let's put it as 3 cases, right? So first case is a minus a squared minus x squared. This is one of the cases. The second case is a squared plus x squared. And the third case is x squared minus a squared. So whenever we have integrals of this kind of form, we can use trigonometric substitutions. So integral. So starting with case 1, let's start with case 1. Case 1 is integrals of this form, a squared minus x squared. So this integral can be rewritten, right? It could be rewritten so we can put it on the right triangle. So we know the right triangle looks something like this. Looks like this, right? Make this a little bigger. Like that. And the right triangle is like this, right? Theta is right there. So what this is basically implying, this integral, is that a squared minus x squared is gonna be right on this side. A squared minus x squared, right? So a squared minus x squared over here. And we want to put the sides, these two sides, in such a relationship that we get x over a, right? We need to put x over a. So in order to do that using this angle, the only way we can do that is using sine. So the x could be here and the a over here, and since we know sine of theta is simply opposite over hypotenuse, so this is opposite over the hypotenuse. We can basically write sine theta is equal to x over a, right? And then we can rearrange this equation so we can solve for x. So we get a sine theta is equal to x. So once we get up to this point, what we can do is actually substitute this in. We can substitute this in for x in the original integral. And then we can follow up, right? We can follow up with the Pythagorean identity. And we're going to be using the Pythagorean identity 1 minus sine squared theta is equal to cosine squared theta, right? This is the Pythagorean identity we're going to follow up with. So the first step would just be this right here, where we try to find what are we working with, right? Which trig function are we working with? And then we follow up with this identity. Then the next case was 2. So we do something similar with the right triangle. So 2, that's the integral of the form a squared plus x squared. I forgot about the dx. So whenever we have something like this is usually this plus sign usually tells us that that's the hypotenuse of the right triangle. So let's use the same right triangle again. Right? And it's usually a squared plus x squared, right, for the hypotenuse. And whenever we have something like this, we want to make sure that we have we can write, what was it? We can put the sides in such a relationship that we have x over a. We have x over a. So in order to do that, we're gonna have to use. So we only have an opposite side and an adjacent side, right? So that means we could actually use tangent. We could use tangent to help us actually write the sides in an x over a relationship. So tangent we know is opposite over adjacent. So what we're gonna do is put x over here and a over here, and when we do that, we end up with tangent theta is equal to x over a. And when you solve for x, we get a tangent theta is equal to x. And we can substitute this in. We can substitute this into the original integral and then follow up with the trig identity. 1 plus tangent squared theta is equal to secant squared theta. Now the third case. Third case is integrals of the form x squared minus a squared dx. So we can use the same right triangle. And whenever we have x squared minus a squared, this is usually going to be the opposite side, right? This is just going to be this side right here. X squared minus a squared. And then in order to get this in a relationship so that it's x over a, we're going to have to use, we're going to need something that lets us put the hypotenuse over the adjacent side. This is the adjacent side, this is the hypotenuse. And we can do this by using secant. Because secant theta is just hypotenuse over adjacent. Since we know cosine theta is adjacent over a hypotenuse, and we know secant is the opposite, right, of cosine. So we can use secant theta. So we can do x over a. And when we do this, we get secant theta is equal to x over a. You solve for you solve for x. Yeah, we solve for x and we get a secant theta is equal to x. Now, after you do that, you have to follow up with an identity. And that's going to be secant squared theta minus 1 is equal to tangent squared theta. So in this video, I just wanted to introduce the topic of trig substitutions. In the next video, I'm going to do an example, and I want to do that example in a separate video because trig substitution can take a very long time to do, and I actually want to do 2 examples, so this video is going to get extremely long, so I want to make the focus of this